Hey guys, this one's going to go a little bit quicker, I think. Even though it looks a lot more complex, it's actually not all that complex at all. Yeah, not at all. So I drew a diagram on the board. So the thing you need to know about this structure that you're seeing here is that it's all based off of a very simple grid, right? That grid and this grid. So I diagrammed like the organizational structure of it, and it's not quite proportional, but it'll do the trick. So like basically what you're seeing here is that it's kind of like this stretched hexagon that creates this secondary space that is like the diamond pattern, right? So it's a diagrid, but it's like an elongated and stretched out diagrid. So what we're going to do is we're going to cellularize a sort of surface, and I'm going to keep it pretty simple for now. I'm just going to show you the gist of it, not like how it engages the ground and all that, because it's really just a subtractive exercise at that point. But really all we're going to do is create cells and then create new geometry with those cells and then build the structural, like the thickness of the structural grid system around that wireframe. And we'll see how much detail we want to get down into today, but that's what you're seeing here. This is the main structural grid, this piece here. So everything either pushes back from that or extrudes forward from it, right? And that's how you're getting all this, all these levels of complexity within it. Oh, that's all old stuff. Turn all that off. Get rid of that. We can work sort of in the same space that we've been working in all day. So let me go to the front view for this, I guess. And I will just start with a rectangle, I suppose. Do I want to do a rectangle? Or do I want to do a grid? I'll just do a rectangle surface. Because we're simulating building it to an actual element, so let's work with this. So I'm going to go to curve, set one curve, and then I can immediately turn that into a surface if I'd like. With this, I'm going to use divide domain squared because each cell is going to be its own entity. And we'll kind of play around with interesting ways of doing this in the future. Anyway, what I'm going to do is, let's see, divide domain squared. We're going to go into surface and pull in isotrim. This stuff is all standard. By now, you're a master of this. Yes. Sure. All right. So yeah, something like that will work. And let's go to something like that. Okay, going back into perspective. Yeah, like this. Okay, so we have our cells. Let me hide that. So the cells, we're going to break down this information so that we can create new geometry. So basically, we're going to rebuild a hex surface, but we're going to build it off of creating new points in these particular locations. So we can use params for that, and you'll see that in just a moment. So we're going to deconstruct this so that we get each individual cell. And then what's interesting about the individual cells is like we can move the points over along the top edge. So we're going to move this point over to there, and then we're going to move this point over to here, and do the same thing on this side. So move that point over, move that point over. On all those cells at once. So we're going to do that by isolating the top and the bottom rail, or the top and the bottom edge of each of the surfaces. So let's go to edge, and we're going to isolate it using list item. That one's the bottom. This one's the top. I'm going to just change the integer to 2. So that one's top, that one's bottom. Or this one's top, this one's bottom. Okay, there we go. So we're going to use, under curve analysis, we're going to use point on curve. So that's going to put a midpoint on the top curve. But if we want to change that, we can actually, well, actually, you know what? I'm not going to use that. I want to have a slider that I can play with rather than having to change two numbers at once. So I'm going to do evaluate curve. Yeah. So if I use evaluate curve, what I can do is set one numerical value. So I can say 0, or actually, let me, yeah, I'll do it with a slider. 0 to 1.00. So let me set up a couple of these and you'll sort of see what's happening. If I put 1 on, well, that 0 is going to put it at the base, but I need to reparameterize it. And now it's going to go from 0 to 1 across the whole length of the top. You guys understand that so far? So I can take that evaluate curve and I can do that on both the top and the bottom. So this one is going to the left and this one is going to the right, right? Do you know why? Who can explain why? Right, but why would it go the opposite direction on the bottom versus the top? Anybody? Okay. So watch the way I draw this rectangle. Okay. Yeah. So when you draw a rectangle, you draw it in a direction, right? And that direction is circular. So the direction of the bottom rail is going the opposite direction as the top rail. So we need to flip one of those. Flip, we can use flip curve. And then when we plug this in, now both of these are going to go in the same direction. Okay? So I'm going to leave it at around 0.2 for now. That should work just fine. And I'm going to do the same operation, but I'm going to do it to the opposite side. Yeah. So copy and paste that down. This one will be 0.8. Actually, no, sorry. I'm going to use the same slider. But this one I'm going to say math, operators, subtraction, and I'm going to subtract it from 1.0. Or just 1. So 1 minus 0.2 equals 0.8, and then 0.8 is going to be used here and here. So all 4 of these now are going to start pinching in. Make sense? Yes. Okay. Now comes the painstaking process of reconstructing this thing. What I do need to find is the midpoints on the other sides. So that's these here. And that's the only other thing I need to reconstruct this. So let's grab, we're going to use the same kind of stuff, except we're going to need the other items. So I can copy and paste this down here. And these are going to be integer of 1 and an integer of 3. So that's going to be your left side and your right side. And then we're going to do the same thing, except we don't need the evaluate curve because it's just going to be the midpoint. So we can just use the easy one, which is point on curve. Boom. That's on one side. This is on the other side. Okay, so that one's super easy. All right, now we have all of the points we need. Now we just need to build it. So when we go to surface, there's a couple of different ways of doing this. I don't recall if I can add points. I can't add points onto the 4-point surface, so I might need to draw lines and use, I think I need to draw lines and then create a boundary surface, because I don't think there's such thing as like a 6-point surface in this. So let's do that. We're going to use boundary surface, and let's go into curve, and we'll draw a series of lines. So let's start from this point right here. We're going to need to draw a line not to that point, but definitely to this point. So we're going to say from here to here. This one is the hex top point, so that's going to be at the top. I'll put it there. And I'm actually going to kind of graphically set this up so that it sort of looks like the lines that I'm trying to create. For me, I think that just kind of makes sense. So we're going to create a little sketchy area for this. So that's the top one. We can create a line for the bottom one, which is going to be from this point to that point. And then we're going to have 2 more, or 4 more actually. So this one we're going to go from the midpoint on the, so this is the midpoint on the right, and this is the midpoint on the left. So I'm going to kind of jostle these around a little bit so that I can see which one's on which side. So if this is on the right, I'm going to go to the right point at the top and the right point at the bottom, which is this. So that, if I'm going to go on this side, is going to be the right point at the top, which is this. See that line? And then if I'm going to do another one down here, this one's going to be the right point at the bottom, which is this one. You guys following so far? Yeah. And then I'm going to do 2 more over here, but these are going to come from this one, and it's going to go to the right point, or the left point at the top, which is that, and then the left point at the bottom, which is that. Okay, so now I've got 1 at the top, 1 at the bottom. I have my 2 on the left-hand side, and I have my 2 on the right-hand side. Okay, so this is that hex configuration. So I'm going to leave that in its hex configuration. I think I should be able to, because these are all going to come out in packs of 1, so you need to look at the data again. See how it's all separate packs? We need to sort of stream all those together so that they're groups of 6. Does that make sense? So that way, like, they're going to be packaged individually, so I can get them all to speak to one another. I should be able to just plug them all in, because it's going to start off with the first item, the first sublist, and then it's going to go to the next one, and it's going to say the first sublist of that, first sublist all the way around. Let's try it. So I'm going to start at the top, go to this, go to that, and that, and that, and that. There we go. Cool. So that worked. Turn all this off. There we go. So that's those. If you're trying to get sort of like a more accurate sort of square pattern, you need to increase the count to get this to be more directly square. So there are a few things that we should do, I think, in order to truly get like the full setup going. So the downside of like creating these hexes is that we have all the hex panels, but we don't have the square panels in between. Even though the example that we're trying to create here includes those squares, right? They're a part of the definition. So we could try to recreate that, or we could try to what's the word? We could try to isolate that, I guess is what I'm trying to say, rather than recreating it. So what I'm going to do is try to I'm going to try to split the surface into separate surfaces using the curves that I have. So let's go to our individual cells. No, not our individual cells. We're going to go all the way back to the base surface. I'm going to grab a copy of this. Make it wireless. Boom. I'm going to call this base surface. So with the base surface, what I want is only the surfaces that are cut by these diagonals. I don't need any others. So I don't need these lines or that line. So I'm going to do a, let's go to intersect, and let's do trim, split beer up actually. Let's do that. Let's try that. let's call it a B-rep. So I'm going to, just in case it needs to be switched to a B-rep rather than a surface. So that's an untrimmed surface. This is untrimmed surface. We'll try it. So it's going to say the B-rep to split. That's that. And then the cutting shape. Oh, that's B-rep split with another B-rep. Sorry. I want... surface split. That's what I want. So let's do the base surface. That's that. And the splitting curves. So let's take all of our diagonals. With the diagonals, I think I want a flattened list. So I'm going to merge all of these. I'm going to take the top left, bottom left, top right, and bottom right. So that merged them into packs of 4. If they're in packs of 4, that might actually work to my advantage. Because if they're in, well, I don't know. Maybe it won't. Let me just flatten it. I'll try it this way. Plug that in. There we go. So let's see what it created. So let me kind of grab like a list item. I just want to see the sort of types of geometry that it created for me. That's good. It looks like the top left corner is trimmed properly. So if I scroll through, that's 0. Oh, that's moving too fast. Hang on. 0 less than 20. There. So looks like bottom corner moving its way up. Outer corner moving its way up. Okay. So it did cut them separately. So here's what I want to check. Let's go to surface and area. I'm going to use area as a way of checking the big surfaces. So there are, looks like there are sets of data that are either going to be 6s, which are the corners, right? So consider that 6, and then 12s, which are the half squares or triangles, larger triangles, and then there are 24s, which are full squares. But if we scroll down, we see these 892. The 892s are, and if that was index value 32, so let's go to list item real quick, and this is 32. That. Okay, because I only cut using the diagonals. So I would want to get rid of those if I can. So what's interesting is I can actually utilize that information to get rid of that information. Now it works really well because this particular definition is kind of like the size of these things are so wide. You know, like the squares are all going to be 24 and these are like over 800. So I can just kind of set like a number that says anything above 30 is going to be removed. Does that make sense? So how do we do that? Let's use, let's kind of work our way backwards. What we're going to use to remove items is going to be call pattern. Call pattern is going to ask me for a list of things to remove, so that's going to be this list of items, and we're going to get rid of some of them. Then I need to define a pattern using Boolean logic, right? So it'll say this one will stay, this one will go, this one will stay, this one will stay, this one will go, right? Using 0s and 1s or using true and false. So with call pattern, what I can do is test each of the surfaces to see whether or not it is above a certain square footage. You remember how to do that? Anybody? We're using familiar tools in a slightly different way with this one. So I'm trying to show you guys how to be a little bit clever about which tools you're using at your disposal. I'll give you a hint. It's under math. So what tool can we use to test whether or not the square footage of each of the panels in the list is higher than a certain value? well, we do need to go to surface analysis and measure the area. Yes. Okay, that's one. No, I think you're kind of on the right track though. So it's under math. It's under operators. Smooth operator. Come on, it's so close. Nope, not mass addition. Smaller than or greater than. So we're going to use smaller than or greater than, doesn't matter. I'm going to use larger than. So we're going to say larger than a particular value. Let's call it 30. So I set this value. It's going to test whether or not all the items in this list are larger than that value, right? So I know that my full square is the size of about 24 square feet, right? I got that right now. So it's going to filter the information out and say false or true, and then I can use that as a call pattern. So if I'm using the false or true side, it's actually going to return, this one is returning all of the larger than items. So actually I should have pulled in smaller than. So let's go to operators, smaller than, plug that in, plug this in, get rid of that, and replace that connection. So now all I have are the squares. And they're all separate items too. Okay, so how are we going to use this? Anybody know? So let's start with, and I'm going to do this kind of in a random fashion, but like when you guys get more intelligent with your designs, you're going to use it in a more intentional way. But I am going to randomly select cells in groups to either move them forward or backwards. Okay, I'm going to do it pretty quick because I'm going to set up one and then I'm going to do the rest certain ways. So all of this information right now is going to be in separate groups, right? We have, well, except for the other one. So this is all in a separate list that looks like this. And this one is in a singular flattened list. I need all this information to just be in one list. So I can flatten this, and then I can merge the two. There we go. Now it's all in one giant list. Okay, that's good because I can just split up that list any way I want. So what I'm going to do here is create a set of numbers, or a series I should say, and then I'm going to create as many numbers as there are items in that list, and then I'm going to randomize that list and then break it up into 3 separate groups. Okay, does that make sense? Actually, I'll probably do more than 3, but so let's kind of go rapid fire here. Okay, so under set sequence we can create a series. A series is going to say what is the first number. First number defaults at 0, which is fine. Does it default at 0? Yeah. And then it'll say the step size. The step size is fine at 1 because I'm going to create index values, indices that I'm going to jostle around. And then it'll ask me for the number. So the number is going to simply be under set list length, however many numbers there are in this list. There. So now we've got a series of numbers being generated from 1 to, oh, that's weird. I thought this was all flattened. Oh, 45 and 60. Flatten that. There we go. 1 to 104. So with that 104, I'm going to jitter that. So that's under set sequence jitter. That's the list we're going to jitter. And now that whole list looks a little different. See how they're sort of all over the place now? That's good. I can change that value later with a seed. So I'm going to say 0 is less than, oh, I don't know, 20. So that's the seed. It just changes the exact configuration. It doesn't change how much it's shuffled. It just jostles them around more. That's an important one. Okay, so now we have our indices, and we're going to use that to split the pattern, right? So we're going to say, let's go with set list. And what we're going to do is, I think we can use pick and choose. Well, maybe. From a set of input data. And that might not be indices. Sort list, pick and choose dispatch. Sift pattern. Leave. Well, actually, how do I want to do this? Sift pattern. I think we might be a little better off with sift pattern. Well, we'll try this first. Okay, so let's do a pick and choose. And so we can partition that list. I'm going to partition them into groups of 10, I guess. No, let's do groups of like 25. Size, partition this list, and let's pick and choose that. Zeros. 25, 25, 25. 2, 2, 2. Nope, I don't want to use pick and choose. All right, I think I'm going to go back and do it a different way. Split list. Extract a subset. Domain. No. Hang on. We can use not explode. Path masks. I'm trying to think of the most efficient way forward. Yeah, let's use sift pattern. 0, 1. Okay, so we can multiply these. Let's do it this way. We're going to do 5 separate groups. We're going to say 0, 1, 2, 3, and 4 are 5 separate groups. And instead of creating a series of numbers, we're going to generate. We're going to borrow this stuff later, but we're going to generate as many zeros, ones, twos, threes, and fours as we need. To fill up the length of the list, which is 105. So we are going to want to, we can do it with a panel if we want, or we could do it a little bit more intelligently. It's up to you. 0, 1, 2, 3, 4. And we're going to repeat data. Repeat. And so this is the data we're going to repeat. We're going to repeat it this many times, right? Because that's the length of my list. So now we have all the numbers. We can plug that into jitter. And now our jitter numbers look like this. We don't need the partition. It's just that. So basically what this is saying is which of the lists that index value is going to filter to. So the elements are the surfaces, that's this, and the pattern is going to be this. So where we have, so that should have some items, right, see that? And then this will have different items. And that'll have a different set of items, so on and so forth. Okay, so each of those can be cleaned. So we want to do clean tree. That's that. I think that cleaned it. No. What was it? What did I use to clean it before? Well, I don't think it's going to be all that critical. We're going to get some errors, but I'll have to fix it later. Anyway, I'm going to give you the gist of it, and then we're going to kind of move on. But basically, like any one of these groups can be isolated. And then when it is isolated, you can do operations on it. So if I have a set of surfaces here, right, these are the elements that I'm going to be working on in that group, or here. So this one I actually like a lot better because it speaks a lot to like what's happening there. So I'm going to move those out and use those to construct new geometry. Yeah, so it's pretty simple. I'm going to do an even simpler version and just say move along a certain axis. So I'm going to move it along the unit Y. It's there, this, and I'll give it a numerical value, which is 0 to, I don't know, 15. Yeah, let's go negative.
I'm sorry, he's so annoying. Oh my goodness.
Thanks.
Sorry.
So let's make this a negative. There we go. And so really at this point, like I don't think I need to take it too much further to show you guys like what else you need to do. But like now we have geometry that we can just go back and extrude into volumes. So all of like the exterior surfaces and stuff. So I have the base surfaces there. I have the new surfaces here. If I deconstruct those, for instance, let's deconstruct that. Copy and paste. We'll deconstruct this. And you just take all of the edges and you can loft them all together and create new new volumes. Well, they're flipped, but let's do flip curve. Let's do this, that, and that. Oh, darn. All right, so there's an ordering thing going on, but you get the idea.
That's pretty cool.
Yeah, let's get rid of that. Okay, so I guess, oh, I know what I'd have to do. It probably happened like way back in the beginning when I, the order that I pulled these together is going to define the direction that each of those lines is going. So a simple flip curve might not be enough. You might need to kind of reverse the input of some of the lines to get them to orient properly. So I don't want to bore you with too much of this, but like this was actually kind of a long definition. Notice how like everything I did got progressively longer. So I'm sorry for that, but I feel like that's pretty educational, right? Is to see the thought process with the diagramming process. The what? The brain frying process? Well, I think the idea is that you won't fry your brain anymore after seeing a more efficient process to getting to the result that you want. So, what questions do you have? No? Okay. So, now you've seen diagramming and how I think through the problems, because I did all of these on the spot, obviously. Like, I didn't prepare for how I was going to do this, right? Think about it ahead of time, develop an action plan. Doesn't always work out the way that you want it to, but then you just start troubleshooting along the way. You know, like whatever roadblocks you hit, try and figure out why it's happening, and then tackle that issue.